Good morning, everybody, and welcome to a new session of the Red Hot. I love the music. It's always put me in a good mood when we have to present something. And the topic today is the OCI service mesh. Let me share my screen real quick. There we go. You should be seeing it. My name is Marta Tolosa. I'm from the Cloud Native Application Development Specialist team. And with me is Mika, and we're going to talk about the service mesh, and he's the one that actually knows everything and is playing around for a while already. So let's get started. Small agenda for today. First, a little bit of context. When do we need a service mesh, and a little bit of these applications that would benefit from using it. The architecture of a typical service mesh scenario, and then a demo. So what are cloud native applications and what are microservices? Because just because your application runs on the cloud, it doesn't mean it's cloud native. New applications are tending more to microservices rather than monoliths. And the old applications are kept as a monolith or are rewritten with microservices architecture. And what are these microservices? They're fine, granular services with business logic, and they're loosely coupled. So you have one microservice with one business logic and another one that's independent with another business logic. And then they communicate between each other via lightweight protocols. And why would this be helpful? Well, imagine you have to onboard a new team member. It's much easier to just teach him or her one microservice than the whole monolith application. Or if you have to fix a bug, it's much easier to fix one bug in one microservice, to test it and to deploy it, than if you have to do the whole application, because sometimes you touch something here and you break something in another corner that you didn't know. Imagine an online shop. In a web page, you have the shopping cart that will be one microservice, the picture where you have all the information about the product, that will be the catalog service. Then you have recommendations for other products that you could buy with that one. That would be another microservice. So each business logic, each functional part of the web page could be one microservice, and they're all put together, and you don't even realize about that. And what are customers doing also? They're doing DevOps. You probably have heard about this concept, developers, and operations together. CI/CD, continuous integration, continuous deployment, continuous delivery, depending how you use it. But it's not a technology. It's a combination of practices. And some people would say it's even like a philosophy, that's the thing here is that there's no human intervention. So the build is automated, but the testing is automated and the deployment is automated. And only a failed test will prevent the change to go into production. You even have an error budget. You're allowed to make mistakes in order to innovate, because do it so quickly and something small, if you have a mistake, then you can either roll back or fix it very quickly. And one of the things here, key things, is automation. Automate everything as much as possible, because then you can see a continuous stream of improvements. And you don't have to automate only if you do microservices. You can start doing that also if you're deploying a monolith. So to start getting used to the concepts. And usually it's a team of developers and operations together. So they both have responsibility and they both make the application in order to run better. And in this team of developers and operations, something that is important could be a service mesh. The service mesh is a solution for managing the communication between individual microservices. Like we said, each microservice has its own business logic, but sometimes they need to talk to each other. So we would have to add the endpoint of one microservice to all others that need to talk to him. So this would be new information that's part of the application deployment code. The communication inside the cluster usually is not secure. So this could be not okay for larger applications that you have sensitive user data, some online app, something like that, some banks. So you would also need this in security in the logic. Or sometimes you need to retry to implement some kind of retry mechanism logic in each microservice. And you also need to retrieve metrics to monitor how your microservice is doing, how many HTTP errors, how many requests, how long was the response time. So this logic might also be added to the service. And this is all non-business logic that you have to add to each application. So your developers are not working on the actual logic, and this adds complexity. So in these developers operations teams, this operational logic is extracted and moved to the Sidecar application. And this acts as a proxy. Then the operators can configure the cluster easily, and the service mesh has this control plane that injects the Sidecar proxy in each pod. So you have one thing with your logic and one thing with the extra things that you need. Additionally, one of the most important features is traffic splitting. So you could have different versions of your microservice and split the traffic, because you can't prove the absence of bugs. So when you have a new version, how do you test it? You just have a canary deployment. You deploy 5% of that new version, and then 95% you leave on the old version. And when it's running a little bit, then you say, okay, there's no bugs, and then I can move everything to the new version. The service mesh is a pattern or a paradigm. It's not everybody can use it, and there's different implementations of it. And one implementation in open source is Istio. I'm sure you've heard it, but of course we have our own implementation and the managed PaaS service, OCI Service Mesh, which is a free service. Like we said, OCI Service Mesh, our implementation also uses a Sidecar model. So the code that implements that network functionality is encapsulated into the network proxy. This architecture relies on the traffic from and to the services to be redirected into the Sidecar proxy. You see here the control plane sends the traffic to the Sidecar proxy, and the Sidecar proxy talks to each other. And the Sidecar, like the name says, it sits alongside the proxy to the pod, alongside the pod. But because they share the same network, namespace, and the same IP address, this allows the containers to communicate via localhost. So we have one thing, the microservice with the functional logic, with the business logic, and then the Sidecar, which is decoupled from this application code that enables the traffic, the security, the connection management, and doesn't require any application code change. So it's completely separated. This will ensure reliable operations. It's easy to scale, it's easy to update, it's easy to maintain, and then it will enable the autonomy of the team, and hence the productivity of the developers will be higher. This is how the architecture of the mesh is implemented in OCI. So the Envoy is the technology, the framework that we use for the Sidecar. This is to the proxy, and here would be your pod running in a container. And what is very convenient also, because all this proxy also collects these metrics that we were saying for monitoring. You'd have in a separate namespace, so your application is running in this namespace, you have another namespace where your monitoring would sit, and you could display this application, this monitoring dashboard. So you gather the metrics with Prometheus, and you would visualize it with Grafana. If you've heard these two names, they usually come together. Prometheus gathers the metrics, and then Grafana displays them. Very commonly used in cloud native applications. So this is the setup of the demo that we are going to show now. We had a session already end of the year, I think it was November, where we had a cloud coaching with customers, and we had a similar demo, but we changed a little bit. Initially, we had the DevOps service. We have a long build spec YAML where we did all the steps. For demo purposes, I think it's more fluid, and we've changed it. We do it with CloudShell. It's the same scripting, but we just do step by step in CloudShell to show it to you. I think it's a little nicer for you to understand the concept. But it's the same, and you can easily move it to the DevOps service if you need to. But for experimenting, CloudShell is great, and that's why we have it like this now. So we have our CloudShell here. The OKE cluster is already deployed. The image from the cluster is in the registry. We have the secrets in the vault, and here we have our service mesh. And what does this application do? This application shows prices in a single page app. The prices are in an autonomous database. And then we have two services, two versions of the same service. That are the ones that display the application. This one returns a static web page, and this one returns dynamic web page. And the price is retrieved from this service with OSOK, with the operator, takes the data from autonomous. If you see something here, for example, the rule, this means how the traffic is split. So the traffic for price will be 100% with retrieve from this one. And here you can say 50-50, you can say 20-80. We will see now how it looks. This is the physical architecture. Is very similar. That one was a little logical and functional. Same thing. We have in one subnet the database, in another subnet the microservices application. The microservices running, version 1 running here, and version 2 running here. And I forgot something to mention here. We have in a separate namespace, we've deployed Grafana also to show, you will see also the traffic split in Grafana. Same thing, we have the CloudShell where we will trigger the mesh and the image for the Docker. It's pushed in the registry. So it's time for Mika to show us the cool stuff.
Alrighty, thank you, Marta. Let me share my screen. Okay, so yeah, let's go. Okay, first of all, let's take a look at my GitHub page where we have this OCI service mesh demo. Like Marta said, it was previously on DevOps, but I converted to CloudShell because it's a bit more easier to test and run your stuff. And once you have it, an idea how it runs, then you can easily move it to OCI DevOps or any other DevOps platform to continue and automate your work. Okay, so yeah, this is how the GitHub repo looks like. So there's a architecture pictures of what we are doing here is, like Marta explained, there's the OKE registry, user browser, and service mesh, autonomous database, and so forth. So I'm going to go through these steps. I have run these steps for you guys earlier, so we are not running these steps live. I'm just showing how this how this demo goes, so you can test and run it on your own or with your customer to try it out. So okay, so yeah, first of all, you need to clone that repo to CloudShell, which I have here. CloudShell is open here. I have cloned the repo. I have my OK cluster running here, and okay, let me go back. Sorry, here the menus are a little bit on top. Okay, yeah. So the prerequisite for the demo is to, okay, you have the OK cluster up and running, and then you have deployed the Oracle services operator for Kubernetes on top of that. That's pretty easy install. So the operator enables services like, okay, service mesh and autonomous database, MySQL being accessible from Kubernetes environment. So you can create services from, using kubectl and so forth. So that's very handy for Kubernetes developers, because they usually want to use just kubectl to operate their environment. In this demo, we're using kubectl for the most part. So we are creating a database, which I have already up and running, but nevertheless, create the database and create the deployment, this mesh deployment, and then a couple of final steps also require OCI CLI as optional. You're gonna see that later. Okay, so let's start with with the demo. So yeah, like I said, I've cloned the repo to my CloudShell, so it's here. Got the files. Then the next step is to set up some variables. Basically, for demo, I only need these two. So the mesh compartment where I'm running the demo, and then the name for the mesh. My mesh is currently pricing mesh, so the name is a little bit different, but anyways. So these need to be set up. And then when you're doing this demo, you also need to set up the certificate OCID, which is part of the mesh setup, and then set up this OCI registry and DNS stuff if you want to, also access the mesh using your own DNS name, like I'm doing here. Okay. Was there something I forgot to mention? Okay, so first of all, you need to set up the then the Kubernetes operator, and then set up the mesh. Well, the mesh environment comes along the operator, so that's done. Okay, let's go forward. So the first step, is to make sure the database is up and running. So you can run this script, copy and paste it to your shell. So it will, if you don't have the database already, it will create the one, but I've done that previously, so we can just run this here to check that it's up and running. So there we have it. It's the price mesh database running as autonomous. So if I go here, we can see the database up and running. So if you don't have it, it will create it for you. Okay, that's the first step in this demo. So then let's build the services, the home and price services to the registry. So we can do that with this command. So build services, and you place your database password here. The one I'm using is basically this one. And that's the name for the database. So but I've already done that step as well, so we can go just see that we have the images running, created. So Docker images, I have them here, and these been uploaded to the container registry using the same script. So we have the home version v1 and version v2. This one is the static web page. It doesn't, use any database in the background. It just shows the values in the static HTML page. And this is the dynamic version that will call the price service to get the values from the database to the page. So this been compiled and built and pushed to the registry with that step. Okay. And then I have deployed these services to OK environment with this command. So deploy services, and these are the scripts that I've created for you. So running this script, we can see that the services have been deployed to my OK environment. So let's check that with the command. Okay, is that big enough? Let me maximize that. Okay. Let's do that again. Okay. So let's see the deployments that I have. Okay, maybe that's a little bit too big. That's better. Okay. So we can see that the home v1 and v2 are running now as deployments in the Kubernetes environment, and also the price component. These ingresses are created in the next step. So actually, if you're running this demo, you wouldn't be seeing this yet. So only these deployments for the services that we created, pushed to OCI registry, and then deployed to OKE. Okay. Okay, now it gets more interesting. So that we have the services running as deployments on OK, then we're going to Massify the app. So this is where where the mesh gets created, the mesh environment or the mesh instance for you. And we can do that by running that Massify App script. And this will take a little bit time. Since it creates all the mesh resources, it's going to take like, let's say, 4 or 5 minutes to run. I've done that already, so we can just go ahead and see the pods that are running there in the environment. So, so we can see that the pods have been created by the mesh, and you can also see that the sidecars are running within the pods. So this means that there is a sidecar attached to the application image. Okay, so we have them up and running. And how does the mesh look like in OCI console? So this is the service mesh console, and this is the one we just created. So let's go in the price mesh, and here you can see the resources. Let me move that screen a little bit. Okay. So what you have here is the virtual services, the home and the price. This is the home page, and this is the price component that gets the values from the database and passes them to the home page. So we have them here. Then if I go into the home service, we can see that there are 2 virtual deployments, the V1 and V2 of that service. And then we have the, sorry, I clicked something. And then we have the route table that tells how the traffic split, or how the traffic is routed between these 2 versions of the service. So let's go into that, and if I click here, view details, we can see that the traffic split for this home service is 2080. And where does that come from? Okay, let me close that. So where does that come from? So when we run this command here, it deploys the YAML file to OK or to the mesh, or to OK to create the mesh, Massify the services, and it's actually here. The YAML file is here. So so the routing policy or the traffic policy is part of this YAML. So we're going to find it somewhere here. So when I deployed this and Massified the app, we told that, okay, there's 2 virtual deployments, to be V1 and V2 for the home, and the traffic split is between 2080, and this needs to be 100 altogether, 100%. So the split is now 2080. Could be 50-50, or I think 50-50 is the default if you have multiple virtual deployments for two instances. So we get 2080. We're gonna see that live soon. And the other thing that's interesting in the Massified file is the access policies. So this is part of, important part of the mesh as well. So you define what kind of traffic is allowed between the services you're running. So here, excuse me, we are allowing traffic from internet using the Ingress Gateway to the home service, and then we are allowing traffic from the home service to the price service. Okay, so that it can make the call. The home can make a call to the price to get the values from database. And then there's also the Ingress Gateway for the admin part of the price service. So we can also update the prices using the admin part of the price component. And that one is the traffic for the database, outside traffic to the database. This could be more fine-grained, but this is just a simple example how it goes. So 2 things, traffic split, and then the access policies are here. Okay, let's go back. So we can actually now, since the application is deployed as a service mesh, we can here, and this is how it looks like. Finally, you see the page. Yeah, this is the same example that I'm using in my many examples for autonomous or for other demos. But yeah. So what you have here is, if I keep reloading this page, Let's put another refresh. Okay, so you can see that this is the dynamic page, and the values here are got from using the REST service of the price component, and this is like the 80% of the traffic should go here based on the traffic split. But once in a while, like this, you're gonna see a static page. The value is a little bit different, and there's no admin link, so the values are statically on the page. They are not retrieved using the other service component. Okay, so you get the idea. That's okay, so let's go back here. We can go to the next step, and yeah, okay, one thing I didn't tell you is that I'm accessing this page using the DNS. So the next step in the demo is actually to set up the DNS to access the mesh, and there you have like two options. So if you have valid or working domain name registered, you can use the OCI DNS very easily. So you just configure, you get the service endpoints using that command, and we can see that the load balancer for the mesh is this, and for the admin, is this one, and for the admin part is this one. And then you can update the DNS very easily, just using this script here. So you place the IP addresses within the script, and then it will create the DNS zone for you, so you can access the mesh using your own DNS name. But if you don't have one, then you can simply update your local host file with the corresponding IP addresses, and then you're able to access it locally with your browser. Obviously, in that case, it's not accessible outside in the internet, outside your local machine. So the DNS is a better option if you have one. Okay, so that is working, and then you can create the monitoring part using this this script here. And for that, you need to export a couple of variables. First, this is part of the mesh setup, or so you need. Actually, if you go here, follow that link, you can see how that log object is created for the service mesh, and then you have to create also create and point to a dynamic group to access that. But it's pretty simple. It's described here quite well how to do that, or actually very well. And then you just run the script. And once you have done that, you can put this command and get the services running in the monitoring namespace. And here we can see that the external IP for that monitoring part is that one. So I can put it here, and then I can access the Grafana dashboard, and here navigate to manage and select the mesh and click here. You get the service mesh dashboard. There are a couple of things you can see here, but most importantly, it's the traffic split. So okay, let me see. So the traffic split is now, okay, sorry, wrong selection. Okay, that's the one I wanted to see. So now we're calling the page, having the other refresh running, so we can see the traffic is coming in here, and the split is, around 2080 as we configure to the mesh. So now you can start playing with the mesh a little bit, and the next one is actually to change the home routing a little bit. So you can do that very easily using that script. So let me put okay, let's do it like 50-50. That's a good demo. So let's do traffic split between these two virtual deployments, equally. So we keep on reloading the page, and we should see that, around 50-50, it's showing the versions of the page. And we should see also here pretty soon that the traffic, the load will start. Okay, it will actually, let me show the mesh. Actually, I forgot to show that. So the traffic rule, once it's updated, maybe it's still doing it. Let me see. It goes to updating stage while it's doing, but now it seems back to active. So probably it's done. So let's see the details. Okay, so the routing traffic split is now 50-50. And going back here, we should see that the traffic will at some point at least now.
Yeah, but it shows already that they're going together to be 50-50.
Yeah, going to that. So let me see. Okay. So it's definitely changing. It will take a while when it gets there, but you can see it's now the traffic is moving. Okay. Then let's wait for a second. But this is what's going to happen. So the traffic split is going to be like that. And where does that come from? The script that I showed, it's calling this update home routing shell script, which uses this YAML file. This is pretty much the same as we had in the original mesh configuration. So I'm passing the values for the weight or for the split here to the YAML, and then we submit this YAML with the shell script. That's pretty easy stuff. And then kubectl apply that YAML, and it will do what I just showed, and change the split of the traffic. Today we don't have, for example, header-based traffic splitting, but that's coming somewhere this spring, like other features. So that's pretty close, that you can actually dynamically do routing based on the, for example, based on the HTTP request header variables and so forth. So that's going to be interesting to test that one out. Okay. So that was basically it. And the last part of the demo is maybe show the KubeShark. So that's a handy tool that works with our mesh. There's instructions how to install it, but the thing is that you need to run that one locally. So I cannot run this one from the CloudShell, so I can run it locally from my own laptop. So with that command, wait a minute. Yeah, let's copy that. Okay. It will access my Kubernetes cluster from this local environment, and then set up with the components that KubeShark is using to access the traffic in that namespace, and then it opens up the local browser environment to monitor your environment and go in and see what's going on. So you can even get like search catalog. It shows the REST endpoints automatically. It shows the the traffic going on here. So you can select between services if you don't want to see everything, and here's the traffic from the ingress to our service components. And you can see the amount of request is increasing while we do it. So you can see traffic going on, and you can investigate or see what's going on in your application. Pretty cool stuff as well. Okay, I'm gonna shut that down. Okay, so as we can see, the traffic is going towards 50-50. So that is exactly how we wanted it. Yeah, I think that's that part.
Awesome. Thanks a lot, Mika. It was really great. Very easy to understand for me as well. So we're done with the demo. As a small recap, this is the triangle, as we call it, the three main components that we have: the microservices application with your logic, the service mesh with the logic of the traffic splitting of the connections, which service talks to each other and is allowed to talk to the outside world, and which one talks to the database, and the DevOps. So we show it with CloudShell, but you would do the same from a DevOps pipeline. You could deploy your Kubernetes cluster, your microservices, the mesh, and change the traffic split. You could do everything from the DevOps pipeline, okay? Or from other tools, from your Jenkins or whatever you want to do it, okay? So, but these are the three main components that we need. So summary, again, all the points. Why would you use a service mesh? To improve the efficiency of your operations, to increase the developer productivity because they only focus on the business logic of the application. Then you have higher visibility end to end. You saw in KubeShare, you can see who is talking to who, how much traffic is going to where, also in Grafana, for example. Then you can connect your microservices dynamically. So in order to change that connection, you would only change these ingress rules to say who talks to whom. And to secure the workload. You saw the price service, for example, it wasn't connected to the outside. It was completely internal, only talking to the home service, for example. If you have, if you want to test out the demo, it's here on the GitHub from Mika, and also some documentation that you could use. And now it's time to take some questions. I see there are a couple here. Let's go to the first one from Rita. Regarding the open source tools we support, Grafana, Prometheus, Jenkins, is there a plan to have OCI cloud native services or continue with marketplace? As far as I know, we have for Jenkins, we have our DevOps service. I don't think we're going to have a Jenkins as a service. I don't think so. No, right, Mika? No, you're shaking your head.
Yeah, so. Yeah, I guess so. Yeah, but using OCI DevOps is pretty straightforward, like discussed. So once you have an understanding what you want to build and how you want to run your app or what you want to actually do in your mesh, then it's easy to get going with OCI DevOps. But of course, it involves all the policies and stuff. So keeping this demo slightly more easier, we wanted to just use the CloudShell with it because it doesn't require so much of setup in the environment. But
and for Grafana and Prometheus, we have also our own logging, our own monitoring as a managed service. I don't think we're going to have a Grafana as a service from us, but it is very easy to set up.
Yeah, these are why I'm using them. It's okay. First of all, they're cloud native. People want to use them and are using them, and also because it's part of the OCI mesh setup. So if you go to the documentation, it describes how to set up the Grafana and Prometheus for you for the service mesh and your components. It requires some configuration, obviously, but if you run the script, it will do it for you, like I showed. Well, ideally, at least. So yeah, it's there. So that's the reason why we are using them. Not.
I know the customers are using them, and I think they all know how to deploy Prometheus and Grafana. So it's not.
Yeah.
And they could, because that's what we hear many times, they want to be independent and agnostic, so they could move this to another cloud provider, to on-premise, and it would still work, or have the same configuration in both cloud providers or on-premise and in OCI. Next question, can you tell something about the complexity of service mesh when compared to using broker like RabbitMQ? I experienced that when you have lots of microservices, the service mesh becomes quite complex.
Yeah, I can take the last part at least. So yeah, the configuration, I didn't actually show it, but if you go to the GitHub, you can see that, it is quite long, and the YAMLs can get easily quite complex. That's true. And they're quite, being YAML files quite challenging, let's say, sometimes to work with, especially if you have a small error there. It can be difficult to find out hopefully we get some better tools around that, some graphical tools or something, I don't know. But unfortunately, I don't have much experience on other options in the market. So this is pretty new stuff for me as well.
We can give this feedback back to PM.
Yeah.
To make it a little more user-friendly. But think if you had this logic in the microservices itself, it would be even worse, I think. So at least you have it separate. You have your mesh and you have your services independently.
Exactly. One thing I could very quickly show, if that's okay with you.
Of course.
One thing is, can I share my screen?
Yeah.
Let me try. Okay. So, when you're calling your services across, inter-traffic communication between the services, when I do the call from, if I remember where it is. So home.js. Okay. So if I do the call from the home service to the price service, doing that REST call is very easy using the names of the services that you have defined. So you just define, host, and then you give the name of the component that you want to access, for instance. Okay, you also need a port, but this is very, easy and handy way within the mesh. At least something that, facilitates your, cross or intercommunication with your services. Yeah.
I saw that you wrote in it, rule of thumb is that you mustn't go for more than 20 microservices because of complexity. Yeah. I didn't know that rule of thumb, but that is good to know. And MQ it's message broker. It's like a queue. It's I don't know. I don't understand the relation with the mesh, but maybe we can take this apart because there is this new queue service, OCI queue, that came, I think, 3 weeks ago. So maybe that's something that could go together with that. Gianluca, are there rules to prevent pods from running with root privileges in the demo?
Ooh, that's a tough one. I haven't thought about that. That's something we can probably check out and come back. I can't answer from top of my head, unfortunately.
But what do you mean with root privileges? Like doing something in the node? Yeah, we'll come back to you, Gianluca, with that one. And I think there's also in the chat some questions. Let me check. OCI native DevOps can do on-prem deployment. Oh, I don't know if we can do on-prem deployments. I don't think so. I think only OCI. Do you know that from the DevOps service, Mika? If we can deploy on-prem?
The service mesh.
No, from the OCI DevOps service.
Sorry, I was reading through those chats.
Yeah, that's a question. It's not relevant to today's topic. If we can deploy from the DevOps service onto on-prem.
Yeah, I would say you can, but yeah, it requires a bit more than just, because there's these helpers in the OCI DevOps where you can select the environment and stuff, but maybe you have to go through
run a script somewhere
or something more complex. So it's not
out of the box. You have to do a dirty thing.
I'm sure you'll get it working, but it requires some more stuff to do around the config.
Exactly. But you can deploy from Jenkins on-prem to OCI or Jenkins in OCI to OCI. You can deploy Jenkins in the cluster or Argo CD in the cluster and deploy in several regions as well. So there's many options. So depending what the customer has and how they have the pipeline set up, then it depends. And I think I saw somewhere sizing of I don't know what it is now, the question. Sizing of the DevOps service. It's difficult to size the DevOps service because you only pay for the storage of the registry where the images are stored, which is very, very small. and you only pay for the time where your build machine is running. So it depends how many builds you do per day. If you do hundreds of builds, then maybe you would pay more, but it's a small VM, so you would pay for that, I don't know, $5 per month max, $10.
Yeah.
It depends how many builds you run.
And actually, good question and an answer. Just reminding me that in the end of your part, you had that link to the Cloud Coach session, where we used OCI DevOps to do this basically same thing. So you can check it out if you want, as additional information regarding OCI DevOps, which we didn't have today. So yeah. But yeah, like I said, the DevOps will consume only for the part when it's running the builds, basically.
So if depending how many builds you have, then
it's like nothing. But if you have like hundreds of builds per day, then the CPU time will be something, depending on your builds.
So worst case would be one machine per month, one compute instance, so to say.
Yeah.
But I doubt that they run for 24/7 their build machine. So I don't know, maybe they do every time they do a commit, they do a build.
Yeah.
But we will have to see what the customer is doing.
It was actually pretty interesting when we still run the DevOps demo last year. Like if you're building these services that we showed today and recreate your mesh environment, the whole thing, not just updating, but really recreating everything as from zero, then the whole DevOps process would take even 15 minutes to run. So it was actually quite long. And that was the reason we didn't do it today, or I don't have in the current demo, because it's a bit long.
We can check the cost, how much we had in the tenancy.
Yeah. And of course, this mesh is quite small, but still, it took around 15 minutes to run completely. Yeah. But then we recreated everything.
Everything, the cluster, the autonomous, everything. So if you just do
a
single change in the code is different.
Yeah. So if you're just building services, that will be like, very easy thing. But when you want to test the whole thing before moving to the upper environment, then it would be something like 15 minutes perhaps, or to run everything. Okay.
I don't think there's any more questions, at least not that I can see.
Well, maybe we give people a minute or so. Please write your questions. We still have a bit of time left.
Yeah. Maybe sharing my screen again while you're thinking. So I don't know if I missed some points in the beginning, but did I show this so that you can actually, that was part of the...
Yeah. You showed everything.
I saw that. Okay, I wasn't sure. So you can also see the autonomous database instance using kubectl. So everything, you can basically do everything using kubectl, which is very handy for the developer. Recreate the mesh components and update and all that. So that's good. But one thing you cannot do is the delete instance. So if I delete this autonomous databases from kubectl side, and it was price mesh db. So if I do that, I just lose the connection from kubectl, but the database doesn't go away. So it will stay. So that's like a safety feature, unlike in Terraform. So if you do that in Terraform, it will delete. But here,
destroy, then it's gone.
But here it doesn't. So it's gone from here. But I can, if I run actually this, it will do a bit more than just the autonomous database, but it really doesn't matter. So if I, my database password is a little bit different, but it doesn't matter because it exists already. So it says namespace is already created. it kind of creates a secret because it's already there. But then it's trying to recreate the autonomous database instance, and it will, realize, it's up and running already, so it doesn't kick it off. But then I can access it again from the kubectl side, so it's there again. Okay.
There was a new question on Q&A. Do we have a clear pro cons versus Istio?
I'm not sure if we have them listed, but yeah, for sure, Istio is a little bit more mature. Because OCI service mesh is still like new, and we're missing the features like, for example, that header-based routing and all that stuff. So Istio is ahead, but other than that, I think we're coming strong.
Yeah, it's still like it's been a while in the market. It's very mature. It's very intuitive. Comes with Kiali also. That this KubeShark that we saw that comes with Kiali is also very graphical. That you see all the traffic.
Yep.
But you can deploy also Istio in OCI. I've had customers before we had the service mesh. We had customers deploying Istio. It's not a managed service. That's the one of difference. Also with DevOps, so when we have a managed service, or with OKE, customers insist sometimes in deploying the cluster themselves, but then you have all this extra work and extra cost. So
yeah, and the good thing about Mesh is that it has all the native APIs for OCI, like Terraform, for the OCI CLI, the SDK. So you can do everything as with any OCI service within your development. So that's definitely a pro, because you have all the APIs to manage the environment. And if you heard about Verasano, which is our packaging for microservices and for WebLogic and stuff, that ships with Istio by default, but I've heard that you could actually run also a service mesh instead, but I haven't tried that. So that's something for the future as well to try out.
I see one more in the chat. How do we stand if compared to competition with cloud providers OpenShift? You mean only regarding the mesh, Robert, or in general in cloud native? I assume just for the mesh. That is a good question. I haven't tried the mesh in AWS or Google Cloud. If they have Istio as a service, I don't think so.
Yeah, I don't know. Sorry.
OpenShift is it's a difficult topic because we can't offer OpenShift also in OCI yet. So
yeah, good point. Probably OpenShift uses like Istio or whatever. I'm just guessing. I don't know. Yeah. Okay, hope you were happy. And keep in touch with us for further questions or demonstrations.
Exactly. Also, all these questions come from customers, so just call us when you have a customer engagement.
If you want to run this demo within customer, in front of the customer, we're happy to do so. And if you want to have guidance how to continue with OCI DevOps, that's also something we can certainly do. Right.
Perfect. Then Marta, Mika, thank you very much for this great presentation. Thanks for the audience for sticking around, for listening in. And then thanks a lot and goodbye, everybody.
Thanks, everybody. Bye.
Bye.